In lesson 9.7, we are going to talk about two special right triangles. We have a 30, 60, 90 triangle and a 45, 45, 90 triangle. These triangles are common, and I will go ahead and draw a 30, 60, 90 looks something like this, where 30 is this small angle here, 60 is that angle, and then you've got a 90-degree angle. So we're talking a right triangle with 30 and 60 as the other two angles. So every time you have a 30, 60, 90 triangle, you can label your three sides with these labels: x, x squared root of 3, and 2x. So the x always goes across from the 30 degrees, so that side is always x. The x squared root of 3 goes across from the 60, and the 2x goes across from the 90. So whatever side length, so in every 30, 60, 90 triangle, however long this side is, the hypotenuse is always going to be twice as long as it, 2 times that value. The other leg is always going to be a square root of 3 times that value. So these proportions to each other will be the same in every single 30, 60, 90 triangle. We're going to use some examples in the next two videos where we use these x, x root 3, and 2x to help us solve for our missing sides. All right, a 45, 45, 90 triangle is going to look a little bit more like this, where you have 90 degrees, and if the other two angles are 45. This is a special common right triangle, 45, 45, 90. So the side lengths are going to be x, x, and x squared root of 2. So your two legs, x and x, of every 45, 45, 90 triangle are congruent. They're the same length. And then the hypotenuse is always going to be the square root of 2 times that value. So what we're going to work on doing is memorizing where these three sides go, and then we're going to use that to be able to solve for the missing sides of a triangle.